Good morning. Today we are going to discuss about ICL 8038 function generator. Function generator is nothing but it is going to generate certain waveforms such as sine, square and triangular waveform. This IC is very much helpful for producing these three waveforms. And this is the pin diagram of ICL 8038. Actually it is a 14 pin IC, and in this 14 pin IC we get three outputs. The outputs are available at the pin number 2, 3 and 9, where 2 is at the second pin we get sine waveform, at the third pin we get triangular waveform, and at the ninth pin we get a square waveform. And the pin number 6 and 11 act as a supply pins to this IC, V plus and V minus or ground. And the 13th and 14th pin does not have any connections. And in addition to that, we have 4 adjust terminals. The pin number 1 and 2 is for sine wave adjust, and the pin number 4 and 5 is for duty cycle adjust. Pin number 1 and 12 sine wave adjust means whenever there is a distortion in the sine wave, it has to be adjusted. For that we have to connect a potentiometer in the pin number 12 in between the pin numbers 12 and 11, or between the terminals 1 and 6. By varying the potentiometers, we can adjust the distortions in the sine waveform. And the pin number 4 and 5, it is called as duty cycle or frequency adjust. So by connecting a suitable resistors between these terminals, in the terminals 4 and 5, we can adjust the frequency of output waveform. And here we have FM bias and FM sweep input. The FM sweep input, here we have to apply the voltage. By applying that voltage, the frequency of the output is maintained constant. There is a purpose of sweep input. Okay, now we are going to discuss about the functional block diagram of ICL 8038. This is the functional block diagram of ICL 8038. This functional block diagram has two variable current sources, two comparators, two buffers, a flip-flop and a sine converter. We know the comparator output is either a plus V saturation or a minus V saturation. The output of the comparators are given to the flip-flop. The flip-flop output is given to the switch and also to the buffer. So the buffer output is a square waveform. The flip-flop output is given to a first buffer, and the output of a buffer is a square waveform. We know flip-flop output is either 0 or 1. The alternate 0 and 1 gives the square waveform. And on a second buffer output we get a triangular waveform. This is achieved from the input of the buffer is from the capacitor, is obtained across the capacitor. We know that capacitor have a charging and discharging time. By adjusting the charging and discharging time, we get the triangular waveform output. And the buffer output is given to the sine converter. This may be a integrator. So the the triangular waveform is given as input a sine converter. It converts or it produces a sine waveform. The frequency of all these signals are controlled by connecting a resistance and external resistance and capacitance connected in the pin number 4, 5 and 10. This is a functional block diagram, and this is a typical waveform of triangular, sine and square waveform. This is the pin description. The pin number I already told, pin number 1 and 12 is for sine wave adjust. Sine wave adjust means if the waveform, sine waveform has a distortion in the output, it has to be adjusted by connecting a pot or potentiometer between the terminals 12 and 11 and between the terminals 1 and 6. And second pin is a sine wave output. In that pin we get a sine waveform as output, and the amplitude of sine wave is 0.22 VCC, where the value of VCC lies between 5 volt to 15 volt. The pin number 3 is a triangular wave output. The triangular wave is available at this pin. The pin number 4 and 5 is for duty cycle or frequency adjust by connecting a external resistors between VCC to pin 4 and VCC to pin 5, and the timing capacitor in the pin number 10 will decide the frequency of the waveform. By that we can adjust the frequency of the waveforms. Pin number 6 is for plus VCC. The VCC value varies between 5 volt to 15 volt. And FM bias, this pin number 7 is also connected along with pin number 8, is used to test the IC. And pin number 9 produces a square wave output. And pin number 10 we have to connect a timing capacitor which decide the output frequency along with the resistors connected in the terminals 4 and 5. And pin number 11 is minus V or ground, and pin number 13 and 14 does not have any connections. So these are all about pin description. And what are the important features of IC L8038 is all the outputs can be obtained simultaneously, and the frequency range ranges between hertz to kilohertz range, and the distortion, there is a less distortion in the output waveform, and low frequency drifts due to change in temperature. We all know what is meant by drift. Here it produces a low frequency drift whenever there is a change in temperature, and this IC is very easy to use. And parameters, the frequency of output waveform is mainly depends on 3 parameters. One is resistor RA, resistor RB and a capacitor C. RA and RB is also called as R1 and R2, and the capacitor C. The duty cycle is mainly duty cycle or frequency adjust is also controlled by connecting the external resistors at the pin 4 and 5 along with the capacitor connected at pin 10. FM bias we already told. This is FM bias is applied at the pin number 7. It is connected along with the pin number 8, and it tests the functions of ICL 8038. It is nothing but what's the output frequency we get from the output. And FM sweep input, I already told that it is the external voltage applied at the pin number 8 to maintain the output voltage output frequency at a constant value. If we want to change the frequency level, we have to connect a potentiometer. By that we can vary the voltage. By varying the voltage we can obtain the variable frequency at this